Okay, today we're continuing Module 5. We're looking at Topic B, Lesson 7. So we're going to take what we learned about area and marry it with a previous lesson of coordinate planes. We did coordinate planes back in Module 3. So today we're going to have a little bit of a throwback Thursday and review distance on the coordinate plane. Everything we are doing today, we did back in Module 3. Tomorrow we're going to take it to the next step and use distance on the coordinate plane to find area of figures on the coordinate plane. So again, tomorrow we'll have another wedding of distance on the coordinate plane and do area on the coordinate plane, okay? So if you struggle a little bit with today, we're going to review it again tomorrow when we take it to the next step. So let's start with our Throwback Thursday and review what we know about distance on the coordinate plane. So if we have a set of ordered pairs, so if we have the same x-coordinate, so if we have 2, 3 and 2, 5, so 2, 3, 2, 5, so when the x-coordinate is the same, which coordinate is different? The y-coordinate is different. So when the y-coordinate is different and the x-coordinate is the same, it creates a vertical line. So now let's take a look when we have the same y-coordinate. So if we have 2, 1 and 4, 1, so over 2, up 1, over 4, up 1. So we have the same y-coordinate, but our x-coordinate is different. That creates a horizontal line. I think there's state assessment, so they're not doing it today. Okay, so just because the school didn't do the pledge doesn't mean we can't. So thank you for bringing that up. So, same x-coordinate is a vertical line, same y-coordinate is a horizontal line. Okay, so I do realize that here I highlighted my y-coordinate to show that my x was the same, and here my y's were the same. I don't want that to get confusing. Gentlemen. But now this picture of little fishermen should look familiar. That was the same picture we used back in Module 3 when we did this. I think it was like Lesson 17. So when we were looking at distance in the coordinate plane, I remember sometimes we had to add the coordinates. Sometimes we had to subtract the coordinates. So let's think about what that meant. So if we had this as our coordinate plane, okay, that's our coordinate plane, and the water line was our x-axis. If I wanted to find the distance from pole to hook, if this was 6 on our coordinate plane, and that was -4, so the top of this pole is 6 units above the x-axis, and the hook is 4 units below. So if I want to find the total distance from pole to hook, I have to find the distance. So from here to here, that's the absolute value of 6 for a total of 6. From the axis to the hook is the absolute value of -4, so the distance is 4. So to find the total distance, I have to add them together. So 6 plus 4 is 10. So because I crossed over an axis, I have to add them together. So if you want to think of crossing over the axis as a plus sign, remind you to add the distances. So from the point to the axis, and then the axis to the other point, you have to add those two distances together. Now this weekend, Memorial Day weekend, anybody going to go to the Jones Beach Air Show? All right. Have you ever been there? We see it on TV. So you could be sitting on the beach looking up at the planes flying overhead. So we're not crossing over an axis. Here is our axis. Our ground is down here. We'll be sitting on the ground, everybody with their cameras looking up. Some of these trick planes are crazy. They can get so close together. So if we wanted to know the distance between these two planes, did we cross over an axis? No, one is not flying under the ground. They are both in the same quadrant. So if this is 10 units above the x-axis, and this is 6 units above the axis, am I going to do 10 plus 6? Is it a total of 16? Is it 16 units between the two? I mean, we could do mental math and knowing that to get from 6 to 10, remember in kindergarten when your nameplate was taped on the top of your desk and it had the little number line on it, and you take your little frog and hop him up and down the number line. So we could picture this as a number line, and we would hop from 6 to 10, and it's how many units? 4. And what do we know about our mathematical operations, to get from 10 to 6? What operation is that? Subtraction. So because both of my coordinates have the same sign, if they're both positive, so if they both have the same sign, whether both coordinates are positive or whether both coordinates are negative, the same sign, we will subtract. So if the coordinates are the same sign, we will subtract. Here, if our coordinates are a different sign, positive and a negative, then we will add. We'll practice some of these to review. But I just wanted to go back and go over the rules again from what we did in Module 3, because it's Throwback Thursday. Okay? I should have put a no picture of myself on there. That would have been fun. All right? Let's practice some, and then maybe it'll sink in. Here is the first picture on your notes. However, they were not too kind to you because they did not number your grid. What I promised to do for tomorrow, the grids we're going to use, I will enlarge them, I will number the axes, and I'll put one enlarged copy on each table so you don't go so cross-eyed. Okay? So very quickly, number your axes. What I suggest is numbering every other line so you have room. So remember we start at 0, so 2, 4, 6, 8. 2, 4, 6, 8. -2, whoops. I would skip every other line. So that's -2, that line. So you just have enough numbered. Well, I counted each line as 1, but I only numbered every other one because there's not enough room. What I'll even try to do is, for your homework, the problem set is the same thing. They did not number the grid for you, although you could probably count. If I get a chance, I'll try to number them and send them home larger. That's another thing. That's our x-axis, and that's our y-axis. Okay, everybody should have a highlighter, because I think the highlighter will be a good strategy if you have a colored pencil. Okay? So let's take a look at the first one. I have all the ordered pairs on the board already to make it a little bit easier for us. Oops, and the distance. All right, I should have deleted that column. But that's okay, so what we really want to focus on is how to write the proof. So taking a look at the first one, line segment AB. So write down the ordered pairs for line segment AB. So that goes from -2 8 to 9, 8. To help us find the distance, we have to look at the coordinates that are different. So with your highlighter, highlight your -2 and highlight your 9. Those are the two coordinates that are going to help us. Distance is absolute value. So to prove it, we have to go from -2 to +9. We're looking for distance, and absolute value is the distance from 0 on a number line. So did I cross an axis when I went from -2 to +9? Did I cross an axis?
Yes.
Yes. Because my signs are different. And I could always double check here. We're looking at AB. So we did cross over the y-axis. This is a horizontal line because my y coordinate is the same. So am I going to add these or subtract these? Add. If you want to rewrite it with your absolute value, then your distance is 11. Let's try another one. So we're looking at BC. Line BC goes from 9, 8 to 9, 2. So now I'm going to highlight my y coordinates. Because my y coordinates are different, I have a vertical line. Did my vertical line cross an axis? No. Because they're on the same side of the axis, and I know that they are on the same side because they have the same sign. They're both positive. So because they have the same sign, I will subtract. So I have the distance to 8, but I don't need that whole distance to 8. I'm only going from 2 to 8. Oh, and because they're the same sign, we are going to subtract. So the distance is 6. So from B to C is here. We could always count. 1, 2, 3, 4, 5, 6. That worked. But we're not always going to have the coordinate pair to check on. So for the next one, our y coordinates are different. So because our y coordinates are different, that's a vertical line. Did I cross an axis?
Yes.
I know I crossed an axis because they have different signs. Different signs. I'm going to add them together. So I have to go from 2 to 0, and then I have to add from 0 to -5. Like that's my fisherman. So 2 plus 5 is 7. All right, try the next one. Highlight the coordinates that are different. So I have to go from 8 to 0 and then 0 to -5. They have different signs, so I crossed an axis, so I have to add the two distances together. So 8 plus 5 equals 13. All right, let's try the next one, except for some reason my screen doesn't seem to be moving. There we go. Okay. So DE, our boys and girls, X coordinate is different. It really doesn't matter if it's the X or the Y in terms of finding the distance. All of the line segments we'll be looking at are either horizontal or vertical. We will not be doing any diagonal lines in 6th grade. So if you're looking at your coordinate plane and your line segment is a diagonal line, you're reading it wrong. Go back and double check. Okay? All right, so we have from 9 to 0, but then we have to keep going down to -2, or going across to -2. So 9 plus 2 equals 11. So this time it's our y coordinates. But now, when we went from -5 to -2, did we cross over the axis? No. So do I want my whole distance from -5 to 0? Do I need my whole absolute value of -5? No, I don't need the whole thing. I only need part of it. So now I'm going to subtract. So 5 minus 3 is 2. Okay? Let's continue. So we're going from -2 to 0, and then we're going to keep going to +6. So the distance is 8. Okay, I did write the numbers backwards on EF, but I just fixed it. My brain went faster than my hand, I guess. So I just corrected that when it was paused. All right, the next one. -5 to +6. So because all of our lines will be horizontal or vertical, one coordinate will always match. Either our x's will always be the same, or our y's will always be the same. If the x's and the y's are different, then that represents a diagonal line, and we're not doing diagonal lines in 6th grade. 7th grade. So we have to go from -5 to 0, so that's the absolute value of -5. And then we have to keep going to +6. So 5 plus 6 is 11. Six to 8. So between 6 to 8, do they have the same sign or different sign? Same signs. They're both positive numbers. So I only have to go from one positive to the other. Now wait a minute. If I have 6 and I have to take away 8 more, that actually would be a negative number. But distance can't be negative. Distance is always positive. So when So I actually am going to do 8 minus 6. But remember, subtraction is not commutative. 3 minus 2 is not the same thing as 2 minus 3. If I have 2 apples and I take 3 away, I can't. I don't have enough. But if I have 3 apples and I take 2 away, I have 1 left over. So subtraction is not commutative. So I have no equal sign there. If you want to draw an arrow, you can. Or when you write your original equation, you can rewrite that. We can rewrite that to the absolute value of 8 minus the absolute value of 6. And then it will be equal of the absolute value of positive 6. Sorry. So you have to be careful when you're setting these up. No, can you sit on the other side, please, so you don't talk to him? Tomorrow, too. So every day, the conversation is a distraction. Thank you. So be careful when you're setting it up, because it does mean something different. And because we're looking at distance, this is line GA. So let's find GA. Here's G, here's A. The distance is 2. So instead of going from 6 to 8, we could look at it as from 8 to 6. Distance can't be a negative number. So if you need to rearrange your numbers for this purpose, you can, even though subtraction is not commutative. All right, let's just look at our remaining answers. So we're going from -2 to +8. We add them because we're crossing the axis. And then last but not least, -5 to 8. questions on any of these?